In this video, we're going to have a look at how to solve simultaneous equations using elimination. Up to now, we focused on solving one equation that was either linear or quadratic. Next, we're going to have a look at how to approach two equations that need to be solved simultaneously and have two different variables, in this case, x and y. That means a pair of x and y that will make both of these equations true at the same time. The application of the algebra will be determining the point of intersection of two graphs. So in this case, there will be one point, one coordinate, which means an x and a y, that will be exactly the same for both graphs f as well as h. For any other point on the graph, for example, if we focus on -2 as the x value, even though they have the same x value, the y value for the one graph and the y value for the other graph are not the same. So by solving simultaneous equations, we are determining the x and y that are the same for both graphs. We are going to have a look at two different approaches to solving simultaneous equations, and in this video we're going to focus on elimination. Example 1. Solve x and y simultaneously. With the elimination method, we are going to aim to eliminate either the x's or the y's in these equations so that we can then solve the other variable. To eliminate a variable, that variable's coefficient should be the same in both the equations. The sign doesn't matter. Looking at our two equations, we have a variable of 1x and 2x, so they are not the same. And for y, we have 1y and again 1y, which means I'm going to eliminate the y. To eliminate the y's, I'm going to take these two equations and write them underneath each other, and then I'm going to add up or subtract the like terms. That will be determined by the sign of the variable that we want to eliminate. In our case, we have -y and +y, which means we can simply add them up to get 0y and eliminate the y. If I now add up the like terms, I will get x plus 2x is 3x, minus y plus y is then 0 and eliminated, and on the right hand side we have 3 plus 9 is 12. Now we have a linear equation with only the variable x in, and to solve x we can divide both sides by 3 to get x is 4. Now that we've determined the value for x, we can substitute this x value into either of the two equations to also determine the y value. If I choose to substitute back into the first equation, I'm going to change the x to 4, and now I only have y left in this equation to solve. So if I get y alone, it will be 4 minus 3, which is 1. Or, as I mentioned, you could also use the second equation and substitute x with 4. When you solve y here, you will also get a value of 1. So here our final answer will be that x is 4 and y is 1. Or if it was part of a question about functions, you could have written the answer as a coordinate. Example 2. Solve x and y simultaneously. This time, the coefficient of x is the same in both equations. Remember that you want to add up the like terms. So when you write your second equation, make sure that the like terms are underneath each other. The 5, I'm now going to write on the left-hand side as -5, and the plus 2y will become minus 2y on the right. This time, the sign of my two x's are exactly the same. So I cannot add up the two equations because then instead of eliminating x, I will have 2x. So in this case, I'm going to have to subtract the second equation from the first one. If I subtract 1x minus 1x, I will have 0 x's left, And then 1 minus minus 5 in reality is 1 plus 5, and that will give us 6. And y minus minus 2y is y plus 2y to get to 3y. Therefore, y will be equal to 2. If again I choose to use my first equation and substitute y with 2, I will get an x value of 1. In example 3, you will see that neither the coefficients of x or y are the same in the two equations, and that means we will have to adjust the equations before we can add or subtract them. You can now choose whether you want to make the coefficients of x or y the same, and I'm going to have a look at x. At the moment, our coefficients for x will be 4 and 2. So I'm going to keep the first equation just like it is, and then I'm going to take the whole second equation and times by 2. That will give me 4x plus 10y equal to 32. When I write this equation down, I will once again ensure that the like terms are underneath each other. So I will start off with 10y plus 4x equal 32. The sign of the two x terms are different. We have a minus 4x and a plus 4x, which means I can add them up to eliminate x. And then I have 3y plus 10y is 13y. Minus 4x plus 4x is 0. And on the right hand side, I will have 7 plus 32 is 39. If I now divide both sides by 13, I will get y is 3. Now I'm going to take the first equation and substitute y with 3. And next I will have minus 4x is equal to 7 minus 9, which is minus 2. If I divide both sides by minus 4, I will have x is equal to a half.